Okay, Algebra 1 fans, our topic for today, this is Notes, Section 1-4, Distributive Property and Combining Like Terms. So our objectives after this lesson, students should be able to, 1, combine like terms, and 2, use the distributive property to simplify expressions. So before we begin, let me tell you your joke of the day here. My friend was explaining electricity and I was like, what? Watt, W-A-T-T, measure electricity in watts. Okay, so the first section here is talking about what like terms are and a couple of examples. The idea of like terms is that they are expressions or terms with the same variables and the same exponents. The same variables and the same exponents. Okay, so an example of what we call like terms, this is a term, this is a term, 3xy, 4xy. They have the same variables and the same exponents. If I said 7x and negative 5x, those are like terms. However, if I said 3x squared and I said 2x, those are not like terms because this one does not have the exponent and this one does. Okay, so those are not like terms. As an example, let's underline all of the like terms in the following example. So we have a line of terms here, and what we want to do is figure out which ones are together, which ones are like. So I'm going to start, now it says underline, I'm actually going to circle some of these. I will start with 2x squared y. So 2x squared y. Now the next term is negative 3x squared y squared. And while this looks close to this one, notice that the exponent for the y's are different. So these are not like terms. So do we have any other x squared y's? Oh, it looks like 5x squared y. The number in front is called the coefficient. I'll write that down in a moment. The coefficients don't have to be the same. It's the variables and their exponents that do. So this is good. We have negative, that's a negative 1 x squared y. So that one works. And we also have negative 4x squared y. So these are all like terms. Now let me take a different color here. I'll take red. And let's go to negative 3x squared y squared. So as we go through, we're looking for other terms that have x to the second, y to the second. No, no. Close, but no, because that's x to the first. Here we go. 10x to the second, y to the second. Okay, now we can also look at a constant, which is just a number by itself, like negative 6. Do we have any other constants? Yeah, we have positive 6. And then the last two here, we have 7z. I'll underline that one. But that is not the same as xy squared. So I'll double underline that to show that they're different. They're different terms. On the side here, I'm going to write 3x raised to the fourth plus 6. Because there's some vocabulary here that's really important. When you have a number in front of a variable, so like the 3 right here, that is what we call a coefficient. Coefficient. We're going to use that term quite often, so this is really important. That is the number that's multiplying the variable. It's 3 times x to the fourth. Now, the variable is the letter x, and remember that a variable is it's a letter that represents an unknown number. Okay, so this could be any kind of number. The small number here, the 4, is what we call the exponent or the power. And then we have the number 6. Now notice that that is separated from the variable. It is not multiplying x to the fourth. It's coming afterwards because there's a plus or there could be a minus sign between them. That is what we call a constant. That does not change. That will stay the same, that value. Okay, so the two big ones are coefficient and constant in terms of like terms. Now, to simplify an expression means to combine all the like terms. So whatever we can put together, we're going to try to do that. So example number 1, simplify 7x plus 2y plus 1x. Now we can only combine, we can only add and subtract if we have like terms. Now I see a 7x plus 1x. We are allowed to add those up. Now when we add those, now you don't need to write this down, but when we add those, what we do is we add the coefficients, that's the 7 and the 1, so we get 8x. The variable does not change. That's not 8x squared or anything like that. So that's 8x. Notice that we still have this term, the 2y. Since we cannot add it to the x's because those are not like terms, it's not the same variable, that's it. That's as far as we can go. That is considered simplified. Okay? 8x plus 2y. You will be tempted to say that's 10xy. But if you do that, you're wrong because we are not allowed to add those. We can only add and subtract like terms. All right, let's take number 2. Negative 3r plus 6s minus 2s. Now that's a positive 6s. That is a negative 2s. Now here's the thing. You'll notice that when I circled this, I circled the symbol in front of that term, the operation. I circled the plus and I circled the minus because I want to remind myself this is a positive 6s, this is a negative 2s. So when I combine those, I can think of this two ways. I can think of it as 6s minus 2s, and 6 minus 2 is 4s. Or I could think of it as 6s plus negative 2s. Either way, I get the same thing here. Because if I add the opposite, that's the same thing as subtraction. Now what's important is that we still have negative 3r in front. I'm going to rewrite that. I just copy that down. Now what's the symbol that I put between them? Well, since 6 minus 2 is a positive 4, I must put a plus symbol between these. I always have to put an operation between different terms. So I need to decide whether it's positive or negative. In this case, it is positive 4s. All right, let's take number 3. Now we have more terms here. So we'll start with 2x squared. I see that with a like term of plus 4x squared. Now I know that this is positive. When it's the first number in the expression, we don't put a plus there. We just know that that's a positive. 2x squared plus 4x squared. We add the coefficients, that's 6. The variable and the exponents stay the same. They do not change. So that is 2x squared plus 4x squared is 6x squared. The way I think of it, if you think of an object, let's say that this is oranges, okay? And x squared is an orange. 2 oranges plus 4 oranges is 6 oranges, right? The oranges themselves don't change. All right, let me use a different color. Positive 3x, that is minus 7x. So I need to do 3 minus 7, which is negative 4x. Now when I say negative 4x, I am subtracting 4x. Okay, I will write this as subtraction. And then the last thing, we have constants, negative 5 plus 1. And when we add those up, negative 5 plus 1 is negative 4. So I write that as minus 4. Now these are all different kinds of terms, so that means we are done. That is simplified. It's as far as we go. Okay, number 4. We have a constant 25 plus 2, and we get 27. And then we have 8a, positive 8a plus 7a. 8 plus 7, we add the coefficients, and we keep the variable. So it's not 15, it's 15a. And are these like terms? No, so that means we're done. All right, now, using the distributive property to simplify expressions. Now remember, distributive property means multiplication, where in this example we have 3 parentheses, 2x plus 5. When you have a number next to parentheses, it means you have to multiply. Now what I'm going to do is I'm going to draw an arc from the 3 to the 2x. To remind myself, I need to do 3 times 2x. And then this is a positive 3. I'll put a plus there. Then I need to do 3 times the other number, which is 5. And now we can multiply here. We're not talking like terms now. When we multiply the coefficients. That is 6x plus 15. Are these like terms? No. So that means we are simplified, because we are not allowed to add those. Now let's say we distribute a negative 4. So I'm going to write it out again. Negative 4 multiplies 5x, and then negative 4 multiplies, and that is a negative 2. I'm going to circle that just to remind myself that is a negative times a negative. So what happens here, negative 4 times 5x is negative 20x, but negative times negative becomes positive 8. These are not like terms. We cannot combine them, so we are done. This is simplified. You have to remember this symbol goes with the next value. That is a negative 2 that we're doing. Now, what I'm doing here with writing this out, you don't have to do that. After you do a few of these, you kind of get used to this pattern. Now, for the last one, number 7, we have positive 1. Now, I'm just going to copy that down. Then we have minus 3 times parentheses 2x plus 1. We do not subtract first because order of operations tells us we have to multiply, but this is a negative 3 that I am distributing. It's not 3, this is negative 3. And I cannot overemphasize how important it is to be sure to use that negative. Don't forget that. Negative 3 times 2x is negative 6x. Negative 3 times 1 is negative 3. Now, when I read this, I will read this as subtraction. 1 minus 6x minus 3. Do we have like terms? We do. We have the constant 1 and the constant minus 3. What is 1 minus 3? It is negative 2, and then minus 6x. Now, one last thing here. A lot of times we will write the variable first. So if you wanted to, if you wanted to say negative 6x minus 2, that is also correct. You can do that. Why are we allowed to do that? Well, that is what we call the commutative property. And that is the end of part 1.